Class, our today's new topic is thermal expansion of liquid. Class, we all know how solid expand now. Like solid, liquid are also expand on heating. Liquid expand much more than solids when heated. Liquid do not have definite shape, but they have a definite volume. Therefore, liquids have only the cubical expansion. It's very important, class. They have not a specific or definite shape, but they have a volume, and volume means, class, they have length, they have breadth, they have height. So whenever we expand any liquid, at that time it expand in cubical expansion. Cubical expansion means, class, their volume expand, and there is one only exception. So class, water on heating from 0 to 4 degrees centigrade contracts, and then further heating it expands. So there is an exception when from 0 to 4 we heat the water, at that time it contracts. So this is only the exception, otherwise all the liquids are expand when we will give heat to them. So with the help of this activity, you can see that liquid expand on heating. This is before heating, and this is your water level, initial level, and when you give heat to this water, at that time you can see the water level rises. So by this activity you can see, class, so whenever we will give heat to any liquid, at that time it expands cubically, and cubically means, class, their volume expand. And next is thermal expansion of gases. Gases also expand when they are heated. Gases expand much more than liquid and solid. So like liquid, gases do not have a definite shape, so they also have only the cubical expansion. Again, class, they have not definite shape, so they also have a cubical expansion, means, class, they are expand in all the direction, in lengthwise, breadthwise and heightwise. It means in 3 dimensional they expand. So this is the expansion of air. Here you can see the air in this bottle, and there is a balloon which we put outside, and when we take this bottle in this boiling water, because of this boiling water, the air inside the jar is heated, and after that, because of heating, it expand, and because of expansion of air, this balloon inflated. Class, we are talking about mode of transfer of heat. Class, we have 3 states: solid, liquid and gas. So if we have 3 different states, then there is not only one way to transfer of heat. There are so many ways by which heat can transfer itself. So there are 3 main ways: conduction, convection and radiation. And class, in different conditions, different kind of way are used by heat. So if I am talking about conduction, conduction is mainly happen in solid. Class, in solid, the mode of transfer of heat is conduction. Yes, class, in gases and in liquid also conduction is there, but in a very some extent. But in solid, this is the way by which heat can transfer itself. And what is conduction, class? When heat is transferred from molecule to molecule. Suppose, class, this is iron rod. If I am talking about solid, suppose this is iron rod. So class, in this solid rod, suppose these are the molecules. So in conduction, if I give heat to this part, then your heat is transferred from this molecule to this molecule, this molecule to this molecule. So molecule to molecule transfer of heat is known as conduction. And because solid have a specific structure of molecule, so conduction is best way to transfer of heat in solid. If I am talking about, suppose, liquid, so liquid have not a specific molecular structure, and suppose if I give heat to this, so from molecule to molecule heat transformation is very difficult, or maybe it happened but in a very less manner. And if I am talking about gases, so these are the molecules, and if you give heat to this gas, at that time if this molecule is getting heated, so it is not pass its heat to other molecule because it is so far from this molecule. So that's why your conduction is not belongs to liquid and gases, and it basically mainly focused in solid. So in solid, the mode of transfer of heat is conduction. Here you can see class, this is a blade of knife, and if we put butter in this knife and if we give heat to this point, then slowly your heat is transferred from this point to this point to this point, or we can say the molecules. So this molecule to this molecule, and your butter is slowly melt. In this activity class, this is a candle, this is aluminum rod, this is solid, and if you give heat to this point, so slowly because of conduction you can feel heat in your hand also. So class, as I told you, for conduction you need solid, but class, in solid also there are two types of solids, which are conductors and which are insulators. In conductors, your conduction is easily going on, very easily, so which allow heat to pass through them, those solids are known as conductors. All the metals are conductors. So class, it's not about solid, any kind of material which allow heat to pass through them, we can say that is conductor. So there is conduction. And if I am talking about insulator, which do not allow heat to pass through them, that is known as insulator. So sometimes class, your solid like wool, cotton, cork are also not give the permission heat to pass through them. So at that time you can say those solids or those material are known as insulator. So it means class, in for conduction it's not necessary that all the solids have a very good conduction process. It's not always happen. It depends on your material is either conductor or insulator. If this is conductor, then it's very good for conduction. If it is insulator, then it's not good for conduction. And class, it's very important. Flowing air is a conductor and still air is an insulator, which is very important. Now class, some application of conductor and insulator in our daily life. An oven is made up of double walls and space between them is filled with wool, cork, etc. The wool and cork are insulator of heat, so they prevent the heat of the oven to escape. Because of insulator, your heat is not passed through them, so that's why your heat is prevent inside the oven. In cooking, utensils and pans are made up of metals such as copper, brass, steels, and the reason behind that, they all are made up of metals, and metals are the good conductor of heat, so they heat up rapidly. Very easily you can cook your food. Cooking utensils, pans and tea kettles are provided with wooden or ebonite handles. You all observe that wooden or ebonite handles are there because ebonite and wood are the insulator, and because of that heat do not pass through them, and you can easily or safely put those things very easily. So we can hold the hot utensils or pans comfortably by their handles. An ice box is a double-walled box. The space between the walls is filled with cork, glass, and these filling materials are insulator of heat, so they prevent heat from outside pass into the ice box. So class, if I am talking about oven or maybe ice box, at that time you can see class, suppose here you have a ice and here in oven you have some material, like you have any kind of material which is very hot. Between these two walls we kept some insulated items like wool, cork. So this is your insulator, this is also insulator. So in oven class, this heat do not pass through this insulator, so the heat remains same inside the oven, so your item is getting hot inside this oven. But if I am talking about ice box, the heat comes from outside, do not pass through this insulated material. So if heat is not coming inside, so your ice remain same there. So because of this insulator class, your object can be cool or maybe hot. So here in summer, ice kept wrapped in gunny bag. Yes class, you all see that suppose this is your ice box, this is wrapped with the gunny bag, and in those gunny bags there are small pores are there, and between those pores air is there, and you all know still air is a insulator, and if there is a insulator between the outer atmosphere and eyes, then at that time, because of this insulator, your eyes remain same for a long time. Next is, we use woolen cloths in winter. Sweaters or in jacket, you have a small pores, and you all know in those small pores air is there, and still air is an insulator, so it behaves like a shield. Because of this insulator, your heat do not pass through this insulator and you feel warm because of that sweater. And one more thing class, in winters our pipes are covered with cotton, because in cotton there are small pores in those cottons, and there is a air which behaves like a insulator, and because of this insulator there is a shield between the outer temperature and your pipe, so your pipe is not freezing in winters.